Thank you all for listening to me. It's really nice to talk to you. When I was in third grade or thereabouts, someone came and talked to me about space, and it was really, really powerful for me. So I hope you all get as excited as I am. But we do have a lot to talk about, so I'm going to just start.
Yeah.
So the center of the solar system, we have the sun. Can you see that? Yes. Okay. Sun. Giant ball of gas. It's so big, in fact, that the individual pieces of the gas, called atoms, are actually getting smashed into each other. And that releases a huge amount of energy and light and heat. And that is why the sun is so bright. And that light and heat heats up all the planets. And it is the reason we have life, among other things, because life requires energy, usually from a star. So that's the sun. And all stars in the universe work like that. They're really hot and big, and the gravity of all that stuff crushes them into themselves, and you get light and heat. So that's the sun. We haven't sent. You can't really land on it. There's nothing. There's no solid surface to land on, but you can study it. So we've sent several spacecraft to orbit the sun and study it up close. So I didn't have an eraser before, so I couldn't do this. So we're talking about. I use the word orbit. What that means is if you have an object like a star or a planet, orbiting means you're going like this around it. You're going around it, and the gravity of the object, which pulls everything in, is actually what keeps you from flying off into space. So that's what an orbit is. And the planets orbit the sun because that's where they formed. Because when the sun was formed a long time ago, it was a giant cloud of gas, and stuff started coming together because of the gravity, and eventually it all started spinning. And so that's how the sun started, and the stuff that didn't become the sun became the planets. So that's the sun. The first planet, as you probably know, is Mercury. It's about 30 million miles from the sun. It's so hot on Mercury that the rock is actually evaporating into space. So there's no air, there's no atmosphere, but there's this constant flow of rock vapor that's rising from the surface because of the sun. The Mercury has no moons because it's so close to the sun that the gravity of the sun would take over and the moons wouldn't stay in orbit around Mercury. We sent a spacecraft to Mercury called Messenger. You can look that up. And it has taught us a huge amount about Mercury. And it's so hot that the spacecraft, if you think you're looking at it like this on the side, it actually has a giant shield. If here's the sun, I should have put it facing the other way. As the spacecraft is exploring, is going around Mercury, it always has to face this giant shield at the sun because otherwise it would get too hot. So that's pretty cool. That's a pretty cool mission. So that's Mercury. Like I said, no moon, super hot. But it's really interesting. Venus, the next planet, is twice as far away from the sun, but it's hotter. And that's strange because usually you think the closer you are to the sun, the hotter it gets. But that's because the distance to the sun is just one thing that determines how hot your planet is. Another thing is whether there's air on the planet and whether that air gets hot also. And Mercury has no, can you see this? Yeah, it looks like it. Mercury has no air, but Venus does have an atmosphere. And so it turns out that when the sun heats up the atmosphere, it can stay hotter, and it can get hotter than if there's no atmosphere at all. So on Venus, it's so hot that diamond and titanium melt. So when a bunch of people sent a spaceship there in the 70s, it lasted for a few hours, and then it actually melted. So diamond and titanium, two of the strongest materials that we have on Earth, they melted. So it's going to take a lot of work to get anything back to Venus and have it last, anywhere near that long. So that's Venus. Venus also has no moons, probably again because it's so close to the sun that the gravity from the sun would prevent something from orbiting for a long time. So that's Venus. Next we get to the Earth, and are we doing okay? Is this a good pace?
Yeah.
Okay. So my goal, by the way, for all of you, I didn't mention it because I know I don't have a lot of time. So I want to tell you about the planets, the moons, and the spacecraft that have visited those places. And I want you to see that any one of you can be part of that in the future if you choose to do that with your life. And I would encourage all of you to think about it, because I did, and it's about the most interesting stuff you could possibly spend your life and your day doing. So, Earth. Earth's a pretty great place to live. There's food and water and oxygen and other people and animals and oceans and rivers and clouds. And as far as we know, this is the only place in the universe that's like that. And we can't be sure of that, of course, but we haven't found anything quite like it yet. So you know a lot about Earth, and this talk is not really about Earth, so we can move on. But what I will tell you about is the moon, which is really interesting. It has no atmosphere. It's about 1/6 the size of Earth. And we think it was formed a long time ago, about 5 billion years ago, when a giant rock smashed into Earth and a big chunk of the Earth got blown away, and it ended up in orbit around the rest of the Earth. So when we look deep into the moon, we actually see some of the same rocks that we see on Earth. So that's where some support for this theory comes from, that the moon used to be part of the Earth. We've sent a lot of spacecraft to the moon. We've sent people too. We sent people went to the moon 7 times. 6 times they got there and landed. The time they didn't land is a mission called Apollo 13, and I suggest you watch the movie as soon as you can, because it's really interesting. And to me, it shows some of the most exciting parts about space exploration. It's human beings working together on really hard problems, being very clever, and solving a huge problem and saving some people's lives. So Apollo 13 is a great movie. Let's see. Okay, yeah, I kind of have to keep up at this pace. So that's the Earth and the moon. The next planet out there is Mars. So Mars is also really interesting. It's about 1/3 the size of Earth. And we have a lot of robots and landers and other things there on Mars over the years that have been studying Mars. One of the most interesting things that we found on Mars and several other places is ice and water. And that's interesting because as far as we know, all life requires water. So if we see water and ice on a planet, that really makes us curious about whether there might be life there now, or maybe there was life in the past. And so the last 10 or so years, or 20 years maybe, of Mars missions have been trying to find water, and we have found water in ice form at the poles, and even small amounts of liquid water on the surface, which is pretty amazing, because even on a hot day, the hottest it ever gets on Mars is about -80 degrees, which is really cold, but there are places on Earth that get colder than that. If you've ever been in an airplane a long way, the air outside the airplane is about -80 degrees when you're flying. So it's cold, but it's not so cold that you can't really relate to it. So Mars has 2 moons. They're called Phobos and Deimos. And they're pretty interesting because we think they were asteroids that have been captured by Mars, by the gravity of Mars, and that they're actually going to collide with Mars in the future in about 10 million years. So they're not in a stable orbit, which means that as they circle Mars, it's not going to last forever. They're actually getting closer to Mars every year. And 10 million years from now, they're going to hit, and it will be quite a show if anyone's around to see it. Hopefully somebody will. We have a lot of different types of spacecraft that have gone to Mars, that are orbiting Mars right now, and that have landed on Mars and are looking around, driving around. There's 2 rovers active right now. One is called Opportunity, and it's been there for about 10 years. Maybe no more than that, 12 years. And the other one is called Curiosity. It's much bigger. It has a lot more tools on it, and it's been there for about 4 years. So that's Mars. It's a really interesting place. So next out from Mars, you have the Asteroid Belt. Just drawing some shapes. The Asteroid Belt's really interesting because we think all the rocks out there came from a planet that never quite formed. So the current thinking is that, like I mentioned, there's this cloud of dust. The dust gets heavy enough that the gravity causes it to condense and become a star. And then what's left over becomes the planets. But sometimes, for various reasons, all that stuff doesn't make it into a planet. excuse me. So what we see in the asteroid belt is a bunch of rocks that, a bunch of rocks that come from the beginning of the solar system and never quite made it to a planet. So we have several space missions out there exploring some of those asteroids because there's 5 billion year old planet chunks that can really teach us a lot about the early solar system and how the planets formed. One of the reasons we think that the asteroid belt became a belt instead of a planet is that the next planet out, Jupiter, is really, really big. It is so big that its gravity actually holds the solar system together. Is among the reasons the solar system has ended up as a stable solar system where the planets stay in their orbits over time. Jupiter is so big that if you think about the atmosphere on the Earth, like an apple, so if you think about an apple, there's this thin skin of the apple and a bunch of, actual meat is what you call it. On Earth, that skin is like our atmosphere. So we have a huge rocky planet with a very thin atmosphere. And if you've ever been on a plane and looked down at the clouds, you'll note you can recall that you are above the clouds, and that's pretty exciting. On Jupiter, though, instead of being like an apple with a skin that is the atmosphere, as in that thin compared to the rest of the apple, on Jupiter it's more like a beach ball full of atmosphere and maybe the tiniest bit, like a pea-sized core, if there even is a core, we don't know. So on Jupiter you can have like a storm here, and then above that a hurricane, and then above that you can have like a nice day, and then above that another hurricane, because the atmosphere is so tall that there's actually enough room for this stuff to actually stack. And on Earth you don't have that for all kinds of reasons, but next time you're on a plane, look down at the clouds and think, if you're on Jupiter, you could look up at the clouds and you could be flying under a storm, under a hurricane, under a snowstorm. Jupiter is just that big. Jupiter also has about 75 moons, and 4 of them are really interesting. Europa, Io, Ganymede, and Callisto. They were actually discovered about 400 years ago by a guy named Galileo, and he discovered them with a telescope that he built out of junk. And this was not great junk like we have now. This was 400-year-old junk. And he still managed to put together a telescope like you could use in your backyard and see these moons. Europa is a really interesting one because it's basically a rocky core with a huge water ocean. It's got more water in it than all of the Earth. And then an ice crust, like a shell of ice around this ocean. And we're sending a spacecraft there in the next 10 years to look for life in the water and some of the ice on the top. The other three major moons of Jupiter, they're also really cool, but in the limited time we have, I think I'm not going to talk about them because you can look them up. Europa is, to me, the most exciting one. Saturn is the next planet out, as you probably know. And Saturn has something very obvious that makes it different than the other planets, is it has a beautiful ring system. And that's a really interesting phenomenon. And the rings are mostly made of little pieces of ice, and they're also in orbit around the planet. So they're not stuck. They move, but from our distance, they don't look like they move because they're kind of featureless, and they look like a flat disk. But they're actually a bunch of little tiny rocks and ice chunks and stuff like that. Saturn also has a ton of moons, at least 70. The 2 most interesting ones to me being Titan and Enceladus. Enceladus is a giant slushy ice ball, and it actually is spraying water out of itself in these geysers, and some of that water actually ends up in orbit around Jupiter, and that makes up one of the rings, which I think is pretty cool. So we would like to send a spacecraft there to look in the ice, gather the ice directly, and look in it for life, or evidence of life. Titan is the other interesting planet, the other interesting moon of Saturn. It actually has rain and clouds and lakes and rivers and snow But it's 300 degrees below zero. So instead of water making up all of that, it's hydrocarbons, like the stuff in gasoline. So you actually have methane ice. And you have the same cycle on Earth, which is rain and flowing water, and then the evaporation and clouds and rain again. But instead of water, it's based on hydrocarbons, which is really weird. But because of all that, we think that that's another good place to look for life. And that life would look really different than Earth life because there's no water. So at the same planet, at Saturn, you have two moons that might have very different kinds of life. Enceladus could have water-based life like we know a lot about. But on Titan, really not sure what we'd be looking for. But it looks like it might be a good environment for life. So moving on, we have Uranus. Uranus is far enough away that we haven't sent a spacecraft to orbit Uranus. Every other spacecraft up until Uranus we've orbited, meaning we've sent something from Earth all the way out there to stay in orbit and study the planet. But Uranus, we haven't done that. It's too far away. But we've flown by it a few times, and what we see is a giant icy world with something very strange about it. It has a ring, but the ring is it's up and down. Rather, it's 90 degrees from what Saturn's ring is. And that's really unusual. And what we think about it is that something a long time ago smashed into Uranus and knocked it over, literally knocked it over. And so instead of the ring orbiting what we would expect like this, it orbits like this. And Uranus also has a bunch of moons, and they orbit backwards. And again, we think that actually, you know what? I misspoke earlier. Out at this distance from the sun, some people think that these objects are actually not from the solar system itself, the moons, that they actually come from outside the solar system and ended up as moons of Uranus and Neptune. So that's a theory that I think is pretty interesting, and we may confirm it someday. So that's Uranus. Neptune. Neptune is really pretty. It's really blue. You don't see a lot of differences on the top of the clouds when you look through a telescope. But what looks really peaceful and serene is actually 1,500 mile an hour wind all the time, going all the way around the planet. So it takes less time for the wind to circle the planet than for the planet to rotate. So imagine if here on Earth you had a storm. You know how sometimes you can see clouds moving if you look at them for a few seconds?
Yes.
So imagine if those clouds moved all the way around the Earth in less than one day. So that is happening on Neptune continuously. So that's Neptune. Pluto, our last planet, I think it's still a planet. It has 5 moons, which is surprising out there because Pluto is so small. But again, you're so far from the sun that the sun's gravity is really not doing much. So if Pluto was close to the sun, you wouldn't probably not have any moons because the sun's gravity would basically take them away. But way out there at Pluto, which is 3 billion miles from the sun, there are these little moons. And what's fun is recently we sent a spacecraft past Pluto. It flew by and took a bunch of pictures. You can see them. You can look them up on Google. And when the spacecraft was launched, we only knew about one of the moons. And so they actually had to change the mission during its flight to account for the new moons that have been discovered. So that to me is one of the most exciting things about space exploration is we're always learning new things. And we're often learning new things from old information. So in fact, Pluto was discovered in 1931 because somebody was looking at a photograph that was taken in 1899. So for all that time, for 32 years, Pluto was sitting there in this picture, and nobody realized it was a planet. They thought it was a star. So it's just continuous discovery and learning about the universe, and to me, that's what makes it so exciting. So I'll let you guys ask questions in a minute, but I don't think I told you what I do, because I was trying to get to the material. I spent 5 years working on designing missions to other planets and thinking of ways to create spaceships and robots and landers to go to these other places and investigate and learn new things. That's most of what I did. So I'd love to take questions. I think you have another 10 minutes or so.
Designing those space vehicles, what is your background? Do you have a...
So that's actually a really interesting question. So I started college as an engineer. I ultimately switched majors. I actually became a space lawyer by my education. But I was so interested in this other stuff that I managed to find a way to do it while I was working at NASA. So I'm an example of not being limited by your formal education and finding a way to do things that are interesting.
A lifelong learner.
Yes.
Are they ever going to send someone out to see if there's another solar system like ours?
So actually, we know there are billions of other solar systems like ours, and we can see them with telescopes. I didn't mention it, but we've actually found 3,000 more planets in the last 20 years than we ever knew about in all of human history. And so it turns out that most stars in the sky that you can see at night, most of them have their own planets. So there's trillions of planets out there.
Wow.
Yeah.
How many Jupiters will there be what if there was 10 Jupiters orbiting around the sun?
So that is a really interesting question. And rather than speculate, I can send your teacher to a website that lets you actually create your own solar system and put your own planets in it and see what happens to them. It probably would not be very pretty for the planets if you had 10 Jupiters. But there's a lot of software tools that you can use to try that out and see what happens.
How big is Jupiter exactly?
How big is Jupiter exactly? Well, you can look that number up yourself, but I can tell you it's 10 times wider than the Earth. The diameter is 10 times that of Earth. And you can fit 100 Jupiters across the sun.
Wow.
Yeah.
It's huge.
And actually, on the topic of Jupiter, of the size of Jupiter, someone asked earlier, I think this is really interesting. So we talked about how when you get a bunch of space dust together, it can kind of come together and form a star. So it turns out that if you have enough stuff to make something about 10 times the size of Jupiter, that's the smallest star you can make. So the biggest planet you could find probably is about 10 times the size of Jupiter, and that's also the smallest star that you could make, about 10 times the size of Jupiter. So across about that area, you're more likely to have a star than a planet. Yes?
What's your favorite planet?
So my favorite planet is Mars. And it's a hard question, but it's Mars because one is close enough we could send people there. It's Earth-like enough that we know how to live there. It may have life. It may have had life in the past. It has lots of water. We could spend 1,000 years exploring it, and we would still have more to discover. So I think that's got to be Mars.
Is it true that the sun is a big yellow dwarf star?
A yellow dwarf star. So I'm not familiar with the term yellow dwarf star. There's a term called red dwarf star. I don't think the sun is currently classified as any kind of dwarf, but I know that in about 5 billion years it will probably become a red dwarf star when it runs out of hydrogen and helium and starts to expand. And then it will be called a red dwarf.
Why does Saturn have wings?
Well, he talked about that. Were you listening?
So it's a really good question, and I don't think we currently know the exact reason, but we've seen that material from the moons can actually become part of the ring system. But I think the theory is that there were very small moons that at some point were ripped apart by the gravity of Saturn, and were actually like shredded down to the little dust and the rocks that make up the rings. I think that's the current theory.
Is there any more planets that we don't know about?
Yes, there are undoubtedly trillions of planets in the universe that we do not know about. Your question may have been about in our solar system. There's some theoretical work that suggests there may be another large planet out past Pluto, but that it probably doesn't have a circular orbit around the sun. And I can't remember, if you Google the term Planet 9, you'll probably find some stuff on that. But yes, lots of planets out there.
Pluto, most people consider Pluto as a dwarf planet. Do you know how Pluto was considered a dwarf planet?
Yes. So let's see. So about 10 or 15 years ago, the group of scientists that was responsible for these things decided that to become a planet, to be considered a planet, an object needs to have three properties, and I hope I can remember all three of them. One of them is it needs to have cleared out its orbit around the sun, meaning nothing else is orbiting at the same distance. So there's that. The other one of the other ones is it has to be circular, I think, or spherical, because if it's too small to even flatten itself into a sphere, it's not a planet. I honestly can't remember the third one, but Pluto did not pass the test because Pluto and Neptune's orbit actually crosses, and for a period of Pluto's year, meaning Pluto's time to go around the sun, which actually is 250 Earth years, Neptune is actually farther away than Pluto, and that's one of the reasons. And I honestly can't remember the whole story there, but it was quite controversial, and it's a good example of how scientists need to communicate better with the global community.
Do you have any strong feelings on Pluto and its status?
I think it's less important what we call it than that the reasons are effectively communicated. Since I was a kid, since all of you were born even, we've found at least 1,000 planets. Since I was a kid, we've found 2,000 or 3,000 planets. And for all of human history until about 1998, we only knew about the planets in our solar system. And in fact, until the 19th century, we only knew about 4 or 5 planets. And so the definition of planet stayed the same for about 3,000 years, since the Greeks started using the word, and then until the outer planets past Saturn were discovered in the 19th century. So basically, definitions change over time, and if something as major as the definition of a planet is going to change, the international scientific community has to do a better job of telling people why.
Does the asteroid belt have any moons?
So the asteroid belt, it's actually a collection of rocky objects. So there's billions of them. So individual asteroids might have objects orbiting them, which you could consider to be a moon. So yeah, we do see that a lot. In fact, I think it's called asteroid Itokawa, Itokawa. I think it has a moon, if you look it up. But if you just Google asteroid moon, you'll probably see some photos of little tiny things orbiting bigger asteroids.
Will they find any other dwarf planets in our solar system, but not in any other solar system, just ours?
Maybe. So if there is anything Pluto-sized that we haven't seen, it's probably way out past Pluto, and that out there it becomes very hard to see planets because they're very far away, and they're moving fast enough that they're hard to see. It's actually easier to see things that are around other stars in some cases, because those are so far away that the motion of the object doesn't take it away from the telescope. So if you're looking at something that's a mile away, it's going to move across your telescope very quickly. But if it's 100 miles away and you can still see it somehow, it has more time in front of the telescope. So it's actually a really hard region in which to see things past Pluto, but closer than other stars.
Does any of the other planets have sister or brothers?
Oh, I see. So Venus is referred to as a sister of Earth because they're very similar in size and in some other properties. in our solar system, we don't see two planets that are as similar as Earth and Venus anywhere else. But out there in the universe, around other stars, there must be planets like that. There must be pairs of planets that are similar. So I think that's probably out there. We just haven't found it yet.
How much ice have you found on Mars?
How much ice have we found on Mars? I don't know the exact numbers, but there's a ton of it. Well, not a literal ton, much more than that. A huge amount of it at the poles. And that, I can draw something. That's because if here's the sun, you see that? And here's Mars. The sun's light goes like this. So this part here is the warmest. That's why the equator on any planet, that's why it's usually hottest around the equator. At the poles, here and here, you get very little sunlight because the poles are pointed perpendicular is the word, perpendicular to the path of the sunlight. So that's why the North and South Pole are so cold on pretty much any planet. We know there's lots and lots of ice at the North and South Pole of Mars and the Moon, actually, and pretty much everywhere we've looked that's not too cold. So out here, this part of the solar system, it's too cold, and we haven't seen the poles anyway. But to answer your question, I don't know exactly. You could look it up, but this is why there is ice at the poles, because the sunlight is not shining on them and melting it.
Right. Well, thank you, boys and girls. What do we
Sure.
say? Thank you.
My pleasure. Thank you.